Okay, campers, it's time for the Anti-Gravity Jar Challenge. You're going to observe and record, try to figure out what's going on, and then try it yourself. So get out the supplies, your container of water, something to collect the water that spills, a jar with the ring, the disc that you previously cut, and a sharpened pencil or pen. Now observe as I demo the first trial. So I have the jar and the lid with no screen in it. I'm going to screw that on the top so the jar is there. And I'm going to pour water into it. I've colored my water so that you can see it more easily. And I'm going to just pour some water in. And then I'm going to put my hand over the top and invert it. I'm going to hold the jar so it doesn't fall. And I'm going to remove my hands at the bottom. So what do you think is going to happen? Well, let's try it and see. So what happened? Yeah, the water spilled out and got into my container that I had here so it would catch it and not make everything wet. So this time I want to repeat it. I'm going to take the lid off and I'm going to put a screen into it, the thin screen. Now I want you to look at this one as a demonstration and then I'm going to have you do the next one. So I put the screen into the lid and I'm going to screw that on so it lays flat, and that's the important part. It can't be all crinkled, it just has to be flat. And so I'm going to do the same thing I did before. I'm going to pour the water in. Let's see if it goes through that screen. The screen's got holes in it. And there it goes. I'm going to do the very same thing. I'm going to put my hand over it. I'm going to invert it. I'm going to hold on to the top and I'm going to keep the palm of my hand straight. Now, did you see what I did? This is what I was holding at first. I made it straight as I could, and I'm going to remove the palm of my hand, holding onto the jar. So we're going to remove the palm of my hand, and what happened? Is that what you thought would happen? Will the water come out? Is it stuck in there? What if I shake it? Yeah, the water can come out. What if I tilt it? Comes out faster, right? Got to think about, why is that water being held back? The short answer is water's surface tension is winning against gravity. It's your turn now. Get out that needlepoint screen as we work together doing trial 3. And look at the holes. They're bigger than the holes that we had in the window screen. We're going to put the screen into the lid. Lays flat in there, much easier. Screw it on, and we're going to repeat it. We're going to pour the water through the needlepoint screen. Here you have a container to catch the water in below it. Go through. I'm going to hand over the top like before. Invert it. Hold on to the jar so it doesn't fall. Now predict what's going to happen. These are larger holes than the window screen. Now notice I'm making my hand flat. I'm going to hold on, I'm going to remove my hand, and the water stays put. Yep, it takes practice. But first note the different ways you can remove your hand. Some people like to slide their palm to the right, others to the left, some to the back, and others remove it downward. Want to try again? Pause the video. Okay, now that you've all had a chance to try that, a testable question is, how big of a hole can you get? This size hole, the water came out. Why did it come out? Sure, the force of gravity was pulling it down. But when we had either the window screen or the needlepoint screen, the water stayed back because the size of the hole was small enough to allow surface tension to take over and help to hold the water back. So the question is, how big a hole? To do that, you're going to use your styrofoam ring that you cut. But we can't pour water through the styrofoam. So we need to fill the water, put the water in the jar first. Screw the top on so it's on nice and tight. If I invert it, what's going to happen? Well, let's try it and see. The water stays back. That surprise anybody? Even if I shake it, the water stays back. There's no holes. So we need to make a hole to figure out the largest hole we can possibly have and still allow the water to stay in. And in order to do that, let's invert this and set it down. I'm going to slide this out of my way. You're going to take a pencil or a pen. I'm going to hold the white behind it so you can see. And you're going to poke a hole into the middle and make sure it's poked in there nice. And then remove it. Now there's my hole. Can you see it? And now what I want to do is invert, but instead of putting my whole palm, just put your finger over it. So put your finger over it, invert, hold over your container so it doesn't spill. If it doesn't, and does it stay? Sure. That hole is not large enough to allow the gravity to take over. Surface tension is still working to hold that water back. So let's go back. How big a hole can it be? To make the hole bigger, put your pencil back in and twist it around. Enlarge that hole. Repeat your trial. Remove your finger and test. And repeat this over and over until the water actually starts falling through. I want you to be sure to measure the diameter using a metric ruler. Measure the diameter of that hole that you got so we can then compare it later. So what's the science? Surface tension wins against gravity. This involves forces of cohesion, adhesion, and atmospheric pressure, which work together to hold the water droplets on the screen and counter the downward pull of gravity. Remember, water molecules are strongly attracted to other water molecules. We say they have an extremely strong cohesive force. Water molecules are also attracted to the screen, but this attraction, called adhesion, is much, much weaker. Note the difference. Cohesion means attracted to the same thing, and adhesion means attracted to something else. Think of cohesion as the stickiness of water to itself, and adhesion of water stickiness to other substances. Think about this activity the next time you take a shower. Use your umbrella or go camping in the rain. And have you ever thought about why it's a bad idea to run your finger down the inside of a fabric tent when it's raining outside? Ponder over that one. And one tip, don't get soap on these screens. It's really, really, really hard to get rid of it once it's there. And in the next challenge, you'll figure out what will happen to the science if soap is around.